So additive manufacturing, what basically is it? As the name implies, it's a production process whereby material is consecutively added to build up a component instead of in many conventional manufacturing technologies where material is subtracted from the component. So within this process, we usually start with a digital representation of a component, so a model, a volumetric model. And then we do a process called slicing, where we create quasi two-dimensional slices of that component, which then in very different types of additive manufacturing technologies are being applied on top of each other so that in the end we actually have a final component. So why do we use additive manufacturing? It's a very recent technology and its benefits are still being explored today, but one of the major benefits of the technology which are being used in the industry right now are in the design and engineering applications. So one of the major advantages of the technology is that it enables a faster time to market. The production technology is readily available when you have a printer and when you have the knowledge how to do the printing of a component. And during already early design stages of your component and during prototyping of your component, during the testing of new designs or customized features of a component, you can already have it printed and then test those advantages of your, or potential advantages of your design in a very early stage of the product development. So that enables a faster and more flexible production and also development of new products, and can then be leveraged also as a more efficient way to get a new component into the market, or even have an old component individualized, customized or optimized. And lastly, there is a very specific benefit of the technology being used in service industries. For example, the replacement or repair of older industrial products, where maybe supply chains are falling apart, or maybe where components are not regularly being used or needed. Additive manufacturing can be used for on-demand production of those kinds of applications. One of the phrases that is often heard when additive manufacturing is being talked about is the phrase of complexity for free. And what that refers to is the fact that when you add material in a process to build up a component, it doesn't really matter what shape that product in the end has. So that is very much in contrast to conventional manufacturing, let's say like milling or casting, where the more curves or the more complex the shape is that you want to produce, the more complex your tool pathing becomes. Additive manufacturing itself is a very recent technology in the industrial market. So it's been used in industrial context for about 30 to 40 years. But it has taken some time, especially in the beginning, to get widespread acknowledgement and also to get the design engineers and the expertise of engineers up to speed with the new capabilities of that technology. And within the last 5 to 10 years, we have seen an exponential growth of the additive manufacturing market worldwide. Additive manufacturing, as it is a quite novel technology as a whole, has still a lot of different technologies that fall under this bracket. So a lot of different technologies are labeled as additive manufacturing. They use a lot of different feed materials, a lot of different production technologies, and also are on very different maturity levels for industrial use cases. So what that means, there is a very broad landscape of different technologies in the additive manufacturing domain, but there are already also some specific technologies which are being widely used in industries today, as aerospace, and energy sectors, and also automotive. And industries with very high requirements, very high standards are already using additive manufacturing for their advantages. So additive manufacturing technologies can be classified generally by the feed material that is being used and the state that feed material is in, whether it's a liquid, whether it's a filament, whether it's a solid, and whether it's a powder, what kind of state the technology or the feed material is in, and in what kind of way the material is then applied layer by layer to build up a component. There is a lot of movement and a lot of innovation still going on in the technology space of additive manufacturing, and new technologies come out every month. But on a general level, these technologies are divided by the state of the feed material and the way the layers are applied on top of each other. So what are some of the additive manufacturing use cases that made the technology so important in the recent years for many different industries? One major factor the technology got its first investments of some big companies is falls under the term of functional prototyping. So during development cycles of new products, you want to test early designs, you want to test some innovative ideas very early, and you want to have a component that can already fulfill the final requirements of that component in an industrial context. And additive manufacturing absolutely helps within that domain. Another important use case, at least in an industrial context, is the spare parts on demand industry, where you can use or leverage additive manufacturing to have some improvements in your sourcing. So if you have some components that have a very complicated supply chain, or that have some very specific suppliers that maybe also went out of business in some time ago, and you have some trouble getting some component on a regular basis, but you also want to save on inventory costs, then additive manufacturing can have some benefits there as well. And most recently, it took some time for the development of additive manufacturing technology itself, but most recently serial components have become a reality in at least metal additive manufacturing, and also we can see it in a lot of use cases, some plastics being used for serial components in an industrial context, where additive manufacturing and its benefits are fully used to have some performance improvements and really make a difference in the industrial world.